On May 22, 1960, the most powerful earthquake ever recorded struck the city of Valdivia on the southwestern coast of Chile. This catastrophic event was quickly followed by something even more devastating. Ocean waves, some as tall as 25 meters, ravaged the South American coastline, leaving 2 million people homeless and killing or injuring thousands more. The waves also caused major damage as far away as the island of Hawaii, over 10,000 kilometers into the Pacific Ocean. Following this earth-shattering tragedy, Western scientists adopted a much older word for this natural disaster.
Tsunami is a Japanese word for harbor wave. They're really formed by seismic activity, by earthquakes, volcanoes, landslides, things like that. That basically displace tremendous amounts of water. They can travel for tremendous distances, really crossing entire ocean basins, and they move very fast at the speed of a jet airliner, more than 500 miles an hour or 800 kilometers an hour.
Wave length can be about 200 kilometers long in the open ocean. That is why people in the sea or even on a boat, you cannot recognize the wave under you. But once they reach to the coast, the wave can increase dramatically. It can be 30 and 40 in the Japanese tsunami 2011. According to the measurements, it can be 80 meters high. So that is a dramatic force.
Historically, the most common cause of tsunamis has been a major earthquake.
In order to generate a tsunami, it is necessary to have a sufficiently large displacement of the seabed. This underwater displacement, following an earthquake, can be related more or less directly to the magnitude of the earthquake.
People use seismometers to detect, because we know most of the tsunami are caused by earthquake. We have a conventional theory, which is we think the earthquake will lift the seafloor up, then that will push the ocean water, so that will cause the tsunami.
A 5.5 magnitude is a threshold at which you start to say that something has happened, but that there is no risk of a tsunami. And then it's from a magnitude 6 where you can start to have very local effects.
The biggest challenge for preventing tragic loss of life in the wake of a tsunami is knowing when and where it will strike and how large the wave will be.
To my knowledge, there's no way to predict earthquakes. We can do probabilistic analysis where we estimate the recurrent rates of a certain magnitude at a certain location over a certain number of years. So we have an idea of the seismic potential of an area and when, on a certain scale, it could happen. But to say that such and such an event is going to take place in such and such a place, with such and such a magnitude, at such and such a time, no, it's impossible.
If you don't even know that there's going to be an earthquake, how can we then forecast that an earthquake is going to produce a tsunami?
On September 28, 2018, French tourist Jean-Marc Pareja, along with his wife Pascal and a family friend, arrive in the coastal city of Palu on the Indonesian island of Sulawesi, never imagining that they are in imminent danger. For them, it is the beginning of an idyllic vacation.
It's a country that we love because of the mentality of the people. Very zen, very nice people. a lot of humor. It's also a country where there are some quite extraordinary landscapes. There are 19,000 islands in Indonesia, so there's a lot to explore. This was our third trip. The first time, we went to Bali and Lombok. The second year, we went to another group of islands called Karimun Jawa. And so the third year, it was this trip to the Togian archipelago.
The trio planned to spend the night in a hotel on the beach near Palu.
The hotel is located on the seafront, so outside the city. There is the road that runs along the coast, and the hotel is next to it. And on the other side is the ocean. The hotel is nice. It was a perfectly normal vacation day there.
At 2:59 p.m. local time, a 6.1 magnitude earthquake strikes the Sigi Regency, a few miles south of Palu.
My wife and our friend are leaving for lunch in the afternoon. And at one point, my wife feels her chair move. But she doesn't think it was bad. She was a little unstable and nothing else.
Jafar Bua, a CNN reporter based in Indonesia, also feels the medium-sized earthquake.
Hari itu saya sementara bersama keluarga di luar.
I was with my family outside the house.
Tiba-tiba terjadi gempa sekitar.
And suddenly there was an earthquake around 3 p.m. and we had to stop eating.
Dan kami harus berhenti makan ketika itu.
And after that, we returned home because this afternoon at 6 o'clock, I have promised the committee of the Palu Nomani Festival to cover the event.
Festival Palu Nomani untuk meliput acara itu.
And my office, CNN Indonesia, has assigned me to cover the cultural festival held by the Palu City government.
Yang diselenggarakan oleh pemerintah kota Palu itu.
2018 marks the 10th anniversary of the local cultural festival. At 6 p.m., hundreds of people, including many international tourists, are gathered on the Talise beach for the festivities. Then, at 6:03 p.m. local time,
I'm reading the French press on my tablet. I'm at the hotel reception because the network is a bit better. And all of a sudden, there's a huge vibration. There are a lot of small buildings with tin roofs. So I think of a gust of wind at first. I say to myself, here's a big gust of wind. And suddenly, I realize that there's no wind at all whatsoever. And then it starts to shake. The table in front of me starts shaking. The bench I'm sitting on starts shaking. I understand very quickly that it's an earthquake. But suddenly, at 6 p.m., a great earthquake occurred. We then left the house as a family, sat on the ground, and took cover looking for a safe place, away from high buildings. Because we were worried the buildings would collapse because of the strong shaking of the earthquake. The shaking is very violent. That is to say, you can't stand upright. Me? I fell on the floor. There is a woman from the hotel who was thrown and fell on her forehead, who opened her forehead, falling to the ground. Everybody falls. Everything falls over. Scooters overturn. My wife, next to her, the ground is sinking, collapsing. And it lasts, it's very difficult to estimate the time, but it lasts 30 seconds, a minute, no more. But it's extremely violent. The noise is deafening, sort of jackhammer noise, but to the power of 1,000.
the earthquake lasts for less than a minute, but its intensity measures 7.5 on the Richter scale. According to the Indonesia Agency for the Assessment and Application for Technology, The earthquake released 200 times more energy than the 1945 nuclear bombing of Hiroshima, Japan. And for the people of Palu, the worst is yet to come.
Forecasting tsunamis is tricky. It's very different than forecasting hurricane storm surge or coastal flooding that comes from a storm, because with forecasting storm surge, we have the benefit of having days' notice of what's going to happen meteorologically, because a hurricane is the forcing mechanism. With a tsunami, the forcing mechanism is often a volcano or an earthquake. Those are harder to predict. The other reason that tsunamis are difficult to predict is that they can travel so far. So, for example, in the Indian Ocean tsunami in 2004, this started with a massive earthquake in Sumatra. The tsunami traveled for such an extent to the west that it soon outran areas where the earthquake was felt.
The December 26, 2004 earthquake in Sumatra was followed by a series of massive tsunami waves, with some reaching 30 meters in height. Communities on nearby coasts received little warning, and an estimated 228,000 people in 14 different countries were killed, forcing scientists to acknowledge that tsunami warning systems needed a major overhaul, particularly in countries with coastal areas on the Pacific Ocean.
Following the Sumatran earthquake in 2004, studies were carried out to try and find out a little bit about the number of tsunamis per year that were observed in each basin on the surface of the planet. 3/4 are indeed in the Pacific Ocean. There are only 4% in the Indian Ocean. So that means that in percentage terms, there aren't many, except that when it happens, we can have catastrophic events, like the one in 2004, for example. And when we continue to look, the Northeast Atlantic, we have about 10%. About 10%, roughly equal of events that generate tsunamis in our areas.
In 2012, the French government agency SUBMERGED created its own National Tsunami Warning Center in Essonne, near Paris.
SUBMERGED is responsible for monitoring all major earthquakes in the Mediterranean area, adjacent seas, and the Northeast Atlantic Ocean.
France is considered to be characterized by moderate seismicity. That is to say that we are not in a context like the Pacific Basin, where there, because of its large subduction zones with very high convergence spreads, we have events that can reach magnitudes 9 quite regularly. We don't have large subduction zones like that. So we have a moderate seismic activity, but moderate seismic risk does not mean no risk of tsunami.
The strongest earthquakes imaginable in the Western Mediterranean, at the North African margin, which extends from Morocco to Tunisia, could be of a magnitude 7.3 to 7.5. In this case, it has been estimated that the tsunami could generate waves on the French coast that could reach 2 to 3 meters in some areas, or even a little more, depending on the configuration of the coastline.
Scientists at the Warning Center utilized traditional tsunami detection technology while developing new methods for the future.
If a tsunami is propagating, it is necessary to observe it. It is necessary to measure it, and in this case, we use tide gauges. These are devices that are installed along the coast and which estimate the height of water, of the ocean or the sea at a given moment, and which allow us to know if a wavefront is propagating through the ocean or the sea.
The center also processes information from tsunami meters, sensors installed on underwater buoys that can detect changes in pressure as waves pass overhead. In the wake of an earthquake, such changes could mean a tsunami is headed toward the coastal areas.
In the event of a strong event, for example, in the Ligurian Sea between Corsica and France, of an earthquake that would be of a magnitude 6 to 5 approximately, and that generates a tsunami wave, waves would arrive rather quickly on the French coasts.
The tsunami warning for civil protection must be sent within 15 minutes. So in general, the operator, between the moment the event is detected and the moment he validates the parameters of the earthquake, it takes between 5 and 8 minutes.
As part of the efforts that are made to transmit this alert, there are exercises that are practiced between us, civil security, and then local authorities and the populations. The city of Cannes, for example, has put in place a certain number of indications on the edges of ports and then on the roads to find out the best ways to evacuate in the event of a tsunami warning and which points need to be reached to get to safety.
In 2018, Indonesian authorities had their own tsunami early warning system, utilizing seismographic sensors, tide gauges, and tsunami meters. But when disaster strikes, nothing works the way it should. When the rumbling of a magnitude 7.5 earthquake finally stops, the coastal communities of the Indonesian island of Sulawesi are in shock. Islanders know that the worst may be yet to come. Indonesia sits on the southwest edge of the Ring of Fire, the most seismologically active place on Earth. 90% of the world's earthquakes take place here, along this 40,000-kilometer rim of the Pacific Ocean. When one of the largest earthquakes in recorded history struck the nearby Indonesian island of Sumatra in December 2004, it was followed by the world's deadliest tsunami.
We have an earthquake of a magnitude 9.1 to 9.3, a fault more than 1,000 kilometers long, which breaks, and then suddenly, 30 minutes later, we have a 30-meter high wave that arrives on the coast.
Actually, no instrument to measure tsunami in the Indian Ocean. So the earthquake, of course, is a surprise. The tsunami is even a larger surprise.
One thing that was quite phenomenal was the retreat of the sea. First of all, the retreat of the sea of 1 kilometer. So imagine when we're on the beach, a retreat of the sea during 20 minutes of 1 kilometer. It gives us an idea of the energy, which will arrive thereafter.
In September 2018, something similar happens on the island of Sulawesi.
The Indonesian archipelago area, that is a region between Indian Ocean and the Pacific Ocean. Those oceans just sitting above several complex of the tectonic plate boundaries. So that on the east, you have the we call Philippine Sea plate. On the west, that's the Indian plate. On the south, there's several small plates like the Sunda plate and the Yangtze plate. So all the boundaries converge in that area. They collide each other or slide each other. So it's easy to generate earthquake.
The September 28th quake originates in the Palu-Koro strike-slip fault zone, 70 kilometers south of the coastal city of Palu, and emits energy northward toward the bay. Local seismographic sensors detect the rupture and trigger an automatic warning of a tsunami. But the warning goes nowhere.
It is this kind of event actually is very challenging for the tsunami warning system, particularly for Indonesian government. In that event, they did have early warning after earthquake, but the communication cut off, right? Because the earthquake, it destroyed the power. So actually the local people did not receive the warning about the earthquake.
The water was out, the electricity was out. There is an alarm, a siren in the distance, which corresponds to the sirens we have in France for natural hazards. We say to ourselves, okay, there is an alarm. So they're still warning people that something has happened. Even if I think that everyone is aware of what was happening, but there you go, that's all. There is no evacuation order. The authorities are not there. That's it.
The annual Palonomani festival continues on Talise Beach. Most of the attendees have no idea that a tsunami is approaching. At 6:10 p.m., the first and largest of 3 tsunami waves reaches the coast.
Very quickly, we see the ocean that is beginning. We have the impression that it is boiling. It's really a rather frightening impression to see the ocean in a form that we've never seen before. On the spot, it feels like 10 minutes, 15 minutes. But in reality, between the earthquake and the tsunami, 3 minutes. 3 minutes passed. It rushes towards us. It's coming really, really fast. It's really, it's not a slow rise in water. It's really a wave coming at us. The first wave hits the pier, which is in front of the hotel, and it makes a big spray of water. And there, at that moment, I said to myself, there's something. They're still a little unconscious, I think, but I said to myself, something is going to happen. And so we decide to move around and get behind the bungalows. So we really didn't think about it. It was more instinct. I have an image of an old man clinging to a tree and being caught in the current, clinging to a tree. And I say to my wife and our friend, there was a tree right next to it, I said. We're clinging to that tree, and we just had time to cling, and the wave came and hit us. The only thing that's important at that moment is to hold the tree, to hang on, not to let go.
3 successive tsunami waves, each between 4 and 7 meters high, inundated the coastal areas.
We are caught up in the water for, I would say, 10 minutes. We were starting to panic a little. We were beginning to lack strength. And then the water started to come down and the current calmed down. So we were able to get back on our feet, and that was it. The worst was over.
Saya belum mendapat kabar apakah tsunami terjadi.
I haven't got any news whether the tsunami happened. But then after a few hours, the tsunami hit Palu Bay. I then checked it.
Tsunami melanda Teluk Palu. Bisa tsunami. Kalau begitu saya harus cek. Saya cek dan di sana
Palu Bay was really sad. The bodies were lying on the road. The carcasses of motorbikes and cars were scattered.
Jenazah itu sudah terkapar di jalan, bangkai-bangkai kendaraan.
Many victims on the streets. Some were injured and some died. And I think it's like a little apocalypse.
Ada yang luka-luka, namun ada yang meninggal dunia. Dan saya berpikir ini seperti kiamat kecil, ini benar-benar dahsyat.
There are vehicles that have been swept away by the current, that have wrapped themselves around palm trees. A car that is completely folded in two. Its alarm rings for a while. This is a really bad situation. This is not kidding. This is a tremendous disaster. We don't look any further. We're too caught up in the how are we doing? What do we do now? How do we get out of it? We're not there too much looking at what's around us. It's we have to find a solution to get to safety.
The water has receded, but the community is not out of danger. People in and around the city of Palu continue to face the threats of collapsing buildings, untreated injuries, tainted water, and aftershocks that could potentially cause more tsunamis with no warning system in place. Everyone is focused on basic survival.
It's 6 p.m., 6:15 p.m. Night is falling, and then we have to make a decision. What do we do to protect ourselves? We know there may be aftershocks from the earthquake, the wave. We don't know if there can be others. All the people who were on the coast, they all went up. The whole population of the coast immediately went upland.
Local authorities soon learned that the crisis is equally dire in the inland area of Sigi Regency. Although the tsunami wave never reached that far inland, entire towns have virtually disappeared. In the wake of a magnitude 7.5 earthquake and subsequent tsunami, authorities on the Indonesian island of Sulawesi learned that the effects of the natural disasters are more far-reaching than anyone imagined. South of Palu City, on the edge of the Palu River Valley, the farming village of Petabo is buried in mud. Scientists say the situation was caused by soil liquefaction. Vibration from the earthquake disrupted the loose, saturated soil of the rice farming region, turning the ground into a substance like quicksand and swallowing the village.
Saya saat itu juga belum mendapat kabar bahwa
At that time, I also had no news that in Balaroa and Petabo in Palu City, then Sibalaya and Jonugi in the Sigi region were hit by liquefaction. This was land burial. The land is like water,
likuifaksi
melted.
pembuburan tanah. Tanah itu seperti air.
It swallows whatever is on it.
Menelan apa saja yang ada di atasnya. Bahkan rumah yang
Even
besar
houses of any size are shifted,
bergeser
almost hundreds of meters from their location.
hampir ratusan meter dari lokasinya
The
semula.
people were then
Orang-orang
buried in the
terkubur
ground.
dalam tanah.
There were also buried
Mereka terkubur
houses.
dalam tanah. Ada juga rumah-rumah yang terkubur dalam tanah.
On the other side of Palu City, the village of Balaroa has also suffered catastrophic losses. Of the development's 2,000 inhabitants, 600 are pronounced dead. Another 1,000 are reported missing. Meanwhile, in Palu City, more than 4,400 buildings have collapsed.
With the night, we didn't see the damage around. We only saw it the next day. But the next morning, I had to go back down to the hotel and everything was destroyed. The whole coastline, all the buildings, the small restaurants, the small shops, they had been cut down by the wave. The road had disappeared. The asphalt had been torn away. It feels like a city after a bombing. There is nothing left. We find ourselves in a sort of community. People who are there and who are in the same state as us, except they have lost their house. There was no more food. There was no more water. They were also looking for their family to see if everyone was alive. So that was difficult.
Disaster management teams from the Association of Southeast Asian Nations rushed to the aid of survivors, providing housing, medical aid, food, and water purification.
Berpikir harus menjadi relawan kemanusiaan.
I then decided I had to be a volunteer for humanity.
Beruntung teman-teman dari Jakarta, kemudian
Luckily,
teman-teman
friends from
relawan
Jakarta
mahasiswa
and
dari
student volunteers from Makassar came to Palu.
Kita menyiapkan gudang untuk menampung
We set up a
kiriman
logistics warehouse to accommodate logistics shipments,
bahan makanan untuk orang dewasa, kemudian susu untuk anak-anak,
adult food ingredients, milk for children, pampers and sanitary
Hanya kami
napkins.
bekerja, kami juga menyiapkan tim
We also
evakuasi
prepared a body
jenazah.
evacuation team.
Para relawan mahasiswa bekerja untuk itu dan kami yang lain bekerja.
Another team distributed foodstuffs to affected areas in the cities of Palu, Sigi, and Donggala.
Di wilayah Sigi, Palu dan Donggala.
They had nothing left, so we felt a little guilty for having them. When we left, we had the impression that we were abandoning them when they were in a really precarious situation.
In early 2019, the Indonesian government reported that more than 2,100 people had been killed, more than 1,300 had gone missing, and an estimated 133,000 had been displaced from their homes. Many of the survivors were injured, unemployed, and suffering from PTSD.
We had the post-traumatic shock when we came back. We are lucky. In Grenoble, we also had a post-traumatic unit at the Grenoble University Hospital. We stayed here for more than 2 months, locked up, not daring to go out. The slightest noise, it scared us to death.
In the aftermath of the humanitarian crisis, scientists studied the disaster itself, hoping to reduce the casualties of similar disasters in the future. But different scientists have reached different conclusions.
2018 Indonesian Palu earthquake and tsunami is a very controversial event. The seismology community has determined the earthquake type and magnitude that is widely recognized. It is a strike-slip earthquake, and the magnitude is 7.5. So people don't think this kind of earthquake can generate a damaging tsunami because the magnitude is that not big, and it is a strike-slip.
The traditional theory of tsunami genesis supposes that tsunami waves are created by the vertical movement of underwater land. In an earthquake, this type of movement occurs when a normal or reverse fault ruptures. However, the 2018 Palu earthquake originated on a strike-slip fault, where the movement of tectonic plates beneath the Earth's surface is side to side.
Strike-slip, that means the two plates moving toward each other, slide each other. It does not generate a significant uplift. That is, does not fit the traditional theory of tsunami genesis. So people immediately think it's a landslide caused that tsunami.
Scientists from the Port and Airport Research Institute in Yokosuka, Japan, theorized that liquefaction might have caused landslides in the coastal areas surrounding the Palu Bay. According to their study, large masses of soil collapsed in the Palu Bay at 9 different locations, and water displacement contributed to the overall energy of the tsunamis. Landslides, including submarine landslides, are a commonly acknowledged cause of tsunamis around the world, including one significant event off the coast of France. Some scientists still argue that there is insufficient evidence for the landslide theory of the Palu tsunami's genesis.
Several research papers mainly using we call modeling approach to test that hypothesis. Actually, after the events, there's several teams we call the international science team or national team in Indonesia to survey that area. None of the team actually find convincing evidence of landslide. There are some areas have landslide signals, but those landslides is very hard to generate that powerful tsunami.
Other scientists, including those at NASA's Jet Propulsion Laboratory in Pasadena, California, have been testing new alternative theories of tsunami genesis, focusing on the 2004 Sumatra quake.
We have satellite data seeing that tsunami, and also seeing the earthquake. According to the conventional theory, if the seafloor uplift causes that tsunami, so there will have a gravity anomaly at the fault area. So that anomaly is supposed to match the ocean volume that caused a tsunami, which is measured at the surface by another satellite.
In order to mitigate the effect of disasters like the one in Palu City, scientists are rethinking their understanding of tsunamis and using new technology to change how the international community responds to them. The 2018 Palu earthquake caused thousands of deaths and hundreds of millions of dollars worth of property and economic damage. It also left scientists wondering how the quake triggered such a massive tsunami. What unseen circumstances produced this deadly wave? And will events like this be more common in the future? To answer these questions, the scientific community is looking beyond the traditional method of predicting tsunamis based on earthquake seismology.
So as we know, seismic data, you can detect the earthquake location and earthquake magnitude. But unfortunately, the earthquake magnitude is not a good predictor of tsunami size. Or some small earthquake can generate big tsunamis, while some large earthquake did not generate tsunami at all.
Indonesian authorities were unable to predict the scale of the tsunami that struck Palu City. The government had 22 tsunami meters situated in open water, but none of them were operational in 2018. The nearest tide gauge was 200 kilometers away from Palu. Even before 2018, the international scientific community recognized a strong need for a more comprehensive tsunami tracking system. After the 2004 earthquake in Sumatra, researchers at NASA's Jet Propulsion Laboratory began studying data provided by existing GPS tracking systems as well as satellites in space. They realized GPS data could detect precise movement of the land, while satellite data could show the exact location of a tsunami at a given time. Using data from these sources for the Sumatra quake, scientists developed a new theory of tsunami genesis.
The main issue, I think, is the forcing mechanism. How the earthquake forces the ocean to generate that monster wave. So that is the question we're trying to understand. We think the horizontal motion of the continental slope caused by that earthquake is contributing to a force to that tsunami. There's only two kinds of energies. The first, we're talking about the vertical motion that only gives ocean what we call potential energy. But if you have horizontal motion, that we call kinetic energy. But that energy is very powerful. That is why we see many of the large tsunamis generated near the coastal boundary or with a steep topography.
The theory applies to the Palu earthquake, which occurred on a slip-strike fault with the horizontal movement of tectonic plates.
So one set of plates push the water into the bay from south, but another plate push the water from south to north out to the bay. So these two energy overlap causes that tsunami that directly hit to the Palu City at the end of the bay. But the energy all combined inside the bay. So the energy have to release somewhere. That is why it's so powerful. That is why so many people die in that city.
The theory not only helps to explain historical events, but also to predict similar future disasters.
Theoretically, the tsunami has a precursor. It is caused by earthquake or landslide or if whatever the volcano as a source of that tsunami. So that means theoretically we have time to do early warning. The key is how we can use technology
The speed of a tsunami is fixed within an ocean. If there is a big earthquake that generates a tsunami at a given place, we know exactly at what time it will arrive. Where it is more difficult to be sure of the impact is the effective wave height at the time of the arrival at the coasts.
GPS can detect land movement, which can be inversely calculated the seafloor motion. So that means that data can be used for tsunami early warning. Since then, we get NASA support to test the real-time GPS, because for tsunami early warning, you have to get real-time data.
In addition to real-time earthquake data, accurate prediction requires a comprehensive knowledge of vulnerable coastlines around the world.
In order to be able to model the impact of a tsunami on the coast in detail, we need to have a good knowledge of the topography, whether it's the topography on land or the topography at sea, which is called bathymetry. On the French coasts, we have a good knowledge of this data, but in other regions of the world, there could be a gap. And as a result, it's more difficult to model the events in these zones.
There is a lot of work being done on this very issue. There are areas of research, whole sections of reflection and research on this subject to refine the most exact estimate of the height of the tsunami at the coastline.
I'm working with we call smart cable community, trying to put sensors on the ocean bottom cable. That is the cable for our world, for the internet communication. That sensor can be detect earthquake, detect tsunami, also detect the ocean change, immediately send to the internet. Because we actually can calculate the tsunami travel wave in the ocean based on topography. We can predict those tsunami arrival time and even the tsunami power quite precisely.
Accurately predicting a tsunami is only half of the challenge. International partners also need to create an early warning system that can instantly and effectively deliver the warnings to anyone in danger.
To do that, we have developing we call mobile tsunami warning system. That means we will put the warning system into your smartphone. So if there's an earthquake occur around you, then we'll give you alert.
Even as technology improves, some worry that tsunamis might become a more frequent danger in the future. With climate change producing more and more extreme weather around the globe, we could potentially see more tsunamis triggered by non-seismic events.
There can also be so-called meteo tsunamis, when there are very strong depressions above the ocean, and this depression moves at a certain speed. Not too far from the coast, there is a bulge in the sea level, and on the front of this bulge, there can be waves which are generated and which finally devastate the coast with tsunamis.
Climate change impacts different parts of the world in different ways. In the Arctic and in the Antarctic, we see a lot of melting sea ice and melting land-based ice and glaciers as well. You can think of the heavy weight of tremendous amounts of ice on land. When the ice melts, the land actually rebounds. You can think of this, if you lay on a mattress and then you suddenly get up, the mattress is going to take a few seconds to really quickly raise up as well. That's what's happening to the land. When we melt glaciers on the land, we get this, what we call rebound, basically the land pushing up.
So some of the ice cap can be actually fall to the ocean, or we sometimes call icequake. So icequake, so that means the ice shelf, almost like a tectonic plate, can be break apart, then fall to the ocean, or force ocean water. So that can generate a tsunami too.
Facing an uncertain future with extreme weather, coastal communities are taking extreme measures to minimize the catastrophic tolls taken by tsunamis.
Protection against tsunamis, in the physical sense of the term, ultimately preventing a wave from approaching the coast, is quite possible. In Japan, they have built dikes all along the coasts and harbors so that tsunamis of certain height cannot reach directly inside cities or ports.
These constructions, at least for a certain number of them, have shown their effectiveness, particularly in the case of the 2011 event, notably in Kamaishi Bay, where we have photos before and after, so before the tsunami and after the tsunami. And we see that the tsunami, because of its devastating size, destroyed a good part of this dike, but it also helped to slow down the impact of the waves in this bay.
Such prevention methods impose exorbitant costs and require local governments and environmentalists to agree on the benefits and potential risks. In Palu City, for example, a high coastal breakwater could cause problems for the fishing industry and threaten to change the local environment and the local culture more than any tsunami. Scientists at tsunami warning centers around the globe say that the best advice for those living in vulnerable coastal regions is to be aware and be prepared.
Very often, when there is an earthquake that generates a tsunami behind it, and we have videos of the area when the tsunami arrives, we always see people staying put and not taking shelter. This means that there is a continuous effort to be made in terms of prevention and risk education for the population.
If you are close to the coast, if you feel an earthquake, the best thing to do as a precaution is to take refuge further inland, high up. Then, if you haven't felt an earthquake, but you see an abnormal retreat of the sea level, that is to say, for a period a little longer than a classic wave, it's a sign of a tsunami, and there, it is imperative you go to shelter further inland and higher up.
Sebenarnya ada pertanyaan orang, kok
People think that this is an infrequent earthquake,
pertama mereka menganggap ini adalah bencana
so they are
biasa.
still in that place.
Gempa bumi
So
biasa.
many victims.
Sehingga mereka tetap berada di tempat itu sampai kemudian tsunami datang. Ada
Then,
pula
how about the warning from the authorities, such as the meteorological agency?
dari lembaga berwenang
I am sure that it will not reach the hundreds of thousands of residents in Palu City.
Palu. Itu saya yakin tidak akan sampai seluruh
Not until the warning, there has been a tsunami,
Palu belum sampai peringatan itu kemudian
so that many people die on the coast of Palu City.
sehingga banyak korban jiwa masyarakat di sekitar pesisir Teluk Palu.
This is indeed a devastating disaster, and we don't expect it.
Bencana yang dahsyat yang tidak bisa kita sangka-sangka. Saya harus tetap di sini, saya bekerja di sini.
I still stay here. I work here. I grew up here. My family is here.
Kemana-mana. Yang kita harus cari
That's why I'm not going anywhere.
cara menghadapi bencana-bencana itu setelahnya.
What we have to look for is how to deal with that disaster.
Bumi, ketika terjadi tsunami, ketika terjadi
We have to prepare ourselves how to deal with earthquakes, tsunamis, and liquefaction.
bisa kita lakukan.
We want to go back to Indonesia because we love this country. We want to see the people who helped us again, because we had a lot of human experiences like that on the spot. People with whom we stayed in contact. And the only way to go back there is to get rid of the anxieties, the fears, and the anxieties that we may have to go back to that place.
In the meantime, an international community of researchers and governments around the globe are working hard to make this seemingly invisible threat more visible and less threatening. In the United States, on the south shore of Lake Erie, is the city of Cleveland, Ohio. It's a place often impacted by large winter weather systems. Betsy Kling is chief meteorologist at local television station WKYC.
This morning started off just about where we thought it would, below zero and just a couple degrees above zero, depending upon where you were. 7 below this morning's low in Worcester, Lorain, 5 below, 3 below in Ashtabula. Mansfield started right at 0, and Cleveland and Akron were 1 above. I will roll into work, and the first thing I do is take a look at what's going on right now in my area. Then I will get into the forecast models. If we have any kind of a storm system in the offing, and I'm constantly hitting refresh on the browser and looking at the model data as it comes in hour by hour. I think a big chunk of my day is coming up with the most likely scenario. All of that is an effort just to try and get people prepared, at least get them in the mindset of what could be coming, especially if it's something that's going to be impactful weather.
Betsy pays particular attention to storms coming down from Canada and across the Great Lakes, creating powerful weather events.
When you have cold air coming across the relatively warmer water of a Great Lake, you are going to have lake effect. And that is a kind of one of the hallmarks of Northeast Ohio weather. We're known for lake effect snow. And when that lake effect snow really gets rolling, you can have some pretty incredible snow totals that come out.
Around here, 70 inches of snow for the season is not unusual. Many cities like Cleveland are well prepared. But there's a more dangerous winter event that meteorologists pay very close attention to. It begins high in the atmosphere above the Arctic Ocean. Humans live and breathe within the lowest level of Earth's atmosphere, known as the troposphere. It's where airplanes and birds fly and storm systems form. Travel higher and you reach the layer known as the stratosphere. It is here a large region of air known as the polar vortex exists.
The polar vortex is an area of low pressure that sits typically right over the pole, so it exists in both hemispheres, so the South Pole and the North Pole.
A low-pressure system is actually a minimum of pressure. But the winds around the lows rotate, and so a jet stream is created. A very fast wind that goes around the polar vortex with extremely violent winds. And these violent winds somehow isolate the air inside the vortex from the air outside. So, visually, a polar vortex would look like a huge whirlwind with a radius of about 1,000 kilometers, a corridor of extremely powerful winds that would be around 30 kilometers high, and that would maintain, in a fixed way, an important and extremely dense layer of cold air.
The term vortex refers to the anti-clockwise flow of air in the North Pole and the clockwise cyclone of air over the South Pole. The associated winds can be extremely fast, up to 300 kilometers per hour.
It separates the subtropics, mid-latitude air from the Arctic air. The air inside the polar vortex tends to be minus 60 to minus 70 degrees Celsius. And this west-east circulation around it acts like a barrier or fence. It keeps the cold air trapped over the Arctic region.
You can have some extreme situations where chunks of the polar vortex will begin to break off and move around the northern hemisphere.
Disturbances of this polar vortex often occur, so that its shape is no longer circular around the pole, but it can be moved, even deformed.
Temperature differences, cold air over the poles, warm air over the equator, are what drive all weather on Earth. With the climate on planet Earth changing, no place is warming up faster than the Arctic. Its ocean and sea ice are currently undergoing a strong warming event, forcing ice to melt, polar bears and walruses to crowd onto shrinking beaches, and reindeer and caribou to starve. The mid-stratosphere temperature over the pole can get up to more than 65 degrees Celsius warmer than normal. When the warmer air weakens the polar vortex, the jet stream can veer off course. Cold air breaks out of its Arctic grip and travels south. The jet stream instability also brings warm air north. Unusual cold air is matched by unusually warm conditions in Greenland, Arctic Canada, and Alaska. As the world ushers in a new year, unbeknownst to the revelers celebrating on this winter night, a threatening historic weather event is forming thousands of miles to the north. Over the Arctic Ocean, warm air is displacing the jet stream and causing the polar vortex to stretch to the south.
Now, when all that warm air rushes into the Arctic region, kind of knocks the polar vortex off its perch there on the North Pole, and it starts to wander.
Without an active upper-level vortex to keep frigid air bottled up over the Arctic, the cold air mass is forced southward.
And I like to think of the polar vortex kind of as a spinning top. Closely held rotation, tight rotation, and then occasionally you get this rush of warm air from lower latitudes, and it kind of that bangs the top, and the top then it starts to wobble. It got pulled, stretched like a rubber band, moves away from its typical place over North Pole, starts wandering at lower latitudes. It could be Asia, it could be Europe, it could be the United States, and where that polar vortex will go, it will take the cold air with it.
The jet stream dips to the south. The cold air mass flows across the frozen snow-covered landscapes of Canada, which keeps the air cool. As it makes its way further south towards the United States, meteorologists begin to take notice.
A piece of the polar vortex begins to shift southward. You go, oh, and it's very interesting, right? Gonna watch that, gonna keep an eye on that one. Do both models or all three models or four models have that chunk of the polar vortex coming toward us? We have to kind of think ahead for people and keep them ahead of the cold air before it gets here. Trying to track those bad boys down, that's where things get a little interesting as far as doing a forecast goes.
We cannot prevent the polar vortex, but we can always possible to forewarn so that people can be aware of it and equip themselves. Polar vortex strength can be possible to forecast few days in advance, but it is not possible a month or season ahead. So we have only limited time frame to prepare ourselves.
When we observe an increase in temperature in the stratosphere, we predict that there will be a possible destruction of the polar vortex, and therefore a possible cold snap. As the models improve, we are able to have relatively reliable forecasts 15 days in advance of the evolution of the polar vortex, and therefore the probability of cold spells in advance.
I think a big chunk of my day is coming up with the most likely scenario. All of that is an effort just to try and get people prepared, at least get them in the mindset of what could be coming. Downwind, longer range, we could be looking at some significantly cold air coming in. Even if that cold air doesn't hit until day 7, I'm talking about it today because that is a huge deal for the folks around here. And when I start telling people something extreme is going to happen, it gets your nerves up a little bit. People are afraid.
The polar vortex blasts its way south over North America, leaving heavy snowfall and ice in its wake, from the Canadian prairie provinces to the American plains and the East Coast. Strong winds prevail throughout the freeze, making the wind chill temperature feel like it's 10 degrees Fahrenheit colder than it actually is. In Boston, Massachusetts, which is covered in over 7 inches of snow, the temperature drops to 2 degrees Fahrenheit. With the wind chill, it feels like 20 below zero. The winter storm of 2014 is just getting started and already breaking records. 23.8 inches of snow in Boxford, Massachusetts, minus 10 below in Fort Wayne, Indiana, 11 inches of snow outside Detroit, Michigan, with temperatures around the state near or below 0 degrees Fahrenheit. Lake Erie begins to freeze over.
Once you're talking about a polar vortex shifting south. You're not talking about just a quick little clipper storm system that moves right through. You're talking about literally a chunk. It's an air mass. Air masses are big, and they need very powerful forces just to get them moving. So we're talking about several days of dealing with this, as long as the pattern is still moving. If the pattern is stagnant, now we could be talking about weeks.
An enormous Arctic air mass is descending on North America, producing high winds, heavy snow, and dangerously cold wind chills. Temperatures plummet from the northeast to the Midwest United States. Businesses and schools are shuttered. Roads begin to close. On this morning, Chicago's O'Hare International Airport checks in at minus 27 degrees Celsius, breaking the previous record for this day. There are 1,200 flight cancellations. On television, meteorologists attribute the massive cold spell to a phenomenon most viewers had never heard of before.
Everybody was just throwing around polar vortex where 2 years before, nobody even knew it existed, except the meteorologists and the geeks.
The polar vortex has existed for billions of years, so it's not a new phenomenon. It occurs every winter. However, TV meteorologists really first used it and introduced it to the media in 2014, where we had this extreme cold.
By 6 p.m. on the evening of January 6, the temperature in Cleveland plunges to minus 24 degrees Celsius, a drop of 45 degrees.
Cleveland and Northeast Ohio, winters can be pretty tough, but when you put the polar vortex into the forecast, now you are literally bringing the Arctic south. And when you bring the Arctic south, that impacts everything. Now you're talking about car batteries freezing and people's tires deflating. You're talking about windows freezing shut. Your cell phone won't work the same, and you're breathing and you're trying to stay warm, and it is so cold that literally the inside of your mouth and your nose would freeze if you didn't have it covered. So when I start putting into my forecast temperatures of 17 degrees below zero, 18 degrees below zero, literally this hurts. This is painful cold. The gloves that you wear are probably not going to be enough if you're going to be outside for any extended period of time.
Hypothermia represents the greatest danger in the face of the cold, since this hypothermia will gradually lead us to drowsiness and even coma, which can lead to death.
In the winter of 2006, James Kim was driving his family through the snowy mountains of the Oregon Coast Range when they got lost in bad weather. Kim set out alone on foot in the cold wilderness to seek help for his stranded family. Frostbite can happen in minutes on any exposed skin. It's the body's survival mechanism, cutting off circulation to extremities to protect vital organs.
The blood no longer reaches the hands, the nose, the cheeks, the ears, and this constitutes frostbite, which will sometimes be difficult to treat. The body will try to fight against the cold, in this case through the dynamic of shivering, which allows us to recover warmth through our body.
Lost in the snow in search for help, James Kim sheds some of his clothes along the way. Medical experts believe he may have become disoriented by hypothermia.
When we reach lower temperatures, around 35 degrees, we already begin to have problems which are generally neurological problems, that is to say, drowsiness, which will finally bring our bodies into a vicious circle. Because if we become drowsy, we are no longer active. We no longer supply heat, and gradually this temperature will decrease with temperatures that become lethal, below 30 degrees, and certainly below 25 degrees.
The body of James Kim was found 11 days later, 7 miles from his family's car. In the United States alone, up to 1,500 people die from hypothermia every year. The elderly, the young, and the homeless are the most vulnerable.
The first thought we have when a cold spell arrives in France is in fact homeless people who do not have the means to maintain a high level of heating and are exposed to hypothermia. Unfortunately, people who die from the cold are often homeless people. It's unfortunate, it's still unfortunate to say that in the 21st century in France, we still have people who die from the cold, but our metabolism needs to have a little bit of warmth. And inevitably, when we have extremely intense cold spells like this, it has impacts that can go as far as death. The Red Cross, from November to March, reinforces its commitment to these underprivileged people in order to put them in more acceptable conditions and, above all, to protect them from the cold during these periods, which can last more than 10 days and is much more difficult to bear than if they lasted only 1 or 2 days.
A cold wave struck much of Europe during the winter of 2012. Temperatures in Paris approached -10 degrees Celsius, 10 degrees below normal. Altogether, the cold killed more than 824 people across Europe and as far south as North Africa. Communities, particularly impoverished ones, need enough lead time to prepare for the next polar vortex. That is the goal of France's National Meteorological Service.
At Météo France, we tend to be extremely vigilant to warn people, which is our main mission, to be able to protect all the people who may be impacted.
To forecast the polar vortex well in advance, in order to save lives, research data is needed from the atmosphere.
We're going to model the troposphere and also up to the top of the stratosphere. We're going to model all this, and supercomputers will allow us to see a little bit of the evolution within this polar vortex. See if it continues to be intense, or if it tends rather to weaken and meander, and be able to see incursions of cold stratospheric air at lower altitudes.
One of the simpler ways for scientists to study the stratosphere is using helium balloons. These very high-tech balloons are capable of lifting a telescope into the stratosphere.
We're going to hang this little box on a big balloon that we're going to inflate with helium, and which will then go up in altitude, and the transmitter will allow us to receive data in real time of temperature, pressure, humidity, and the GPS position will allow us to deduce the wind. We will be able to go very high in the stratosphere to be able to observe these extremely cold temperatures. In fact, it can go up to 20, 30, 40, 50 kilometers in altitude before it explodes, and then gravity will cause the box to come back down to Earth.
At this altitude, it's difficult to obtain measurements using more conventional means such as airplanes. And weather balloons cost less than a sounding rocket or a satellite. The United States and France are the world leaders in the development of weather balloon technology. Another tool to measure the polar vortex is LIDAR, which stands for Light Detection and Ranging. It's a remote sensing method that uses a laser to measure surfaces of the Earth. Combined with other data, LIDAR generates precise three-dimensional information about the shape of the Earth and its surface characteristics.
LIDAR are extremely sophisticated instruments. They involve sending pulses of powerful laser beams into the atmosphere. Based on this return signal, we can determine the properties of the atmosphere. Measurements we make, in particular of temperatures and winds, allow us to detect disturbances in the stratosphere. For example, sudden heating of the stratosphere, which then propagates towards the poles, which can lead to the destruction of the vortex. We're in the process of setting up real-time data analysis systems that can then be used to validate the forecasts of the weather models in near real time.
Le leader spatial.
The European Space Agency's Aeolus Space LIDAR was launched in 2018 and is currently in operation. This is the first time we have direct wind measurements from space on a global scale. There is also a future for LIDAR in space.
4 days into the cold wave that grips the United States, Babbitt, Minnesota reports the coldest place in the country at minus 37 degrees Fahrenheit, minus 38 degrees Celsius. The cold air reaches as far as Dallas, Texas, which experiences a low temperature of 16 degrees Fahrenheit and minus 9 degrees Celsius. 3 Amtrak trains are stranded overnight west of Chicago due to ice and snowdrifts on the tracks.
Here in Northeast Ohio, in the midst of the polar vortex in 2014, and you're talking wind chills 35 to 40 below zero, and it had been a very long time since we had anything that cold. So the wind chill is a calculation of the heat loss from your body in extreme cold temperatures. The heat loss is expedited, so you lose more heat when the wind is blowing. The heat is literally being just taken off of your body. And in 2014, we had some incredibly low wind chills. You know, I know the northern part of the Great Lakes, they started to get into where you're talking 50 degree below zero wind chills. I mean, that is like Siberian level wind chill. We don't get that around here very often. The city had to be ready for water pipes bursting, water mains bursting, because the ground is so cold, and literally it shifts the ground when you have a deep freeze. And so we had a lot of water mains that were bursting here in Northeast Ohio and beyond. My dad was a firefighter, going out fighting fires, and you're standing next to a burning building, you're spraying water on a burning building, and it's 15 degrees below zero. Guess what's gonna happen? That water is going to turn to ice if it touches you. My dad has had his helmet frozen on his head before. You know, the exterior of his boots were encased in ice in some instances.
In Ohio, schools across the entire state are closed. Ohio State University shuts down, delaying the start of the spring semester. The extreme weather causes the cancellation of some 20,000 flights, along with widespread road and rail delays.
A big part of my job is kind of holding hands with people and helping to guide them through days on end of extremely cold air. I'm still the one that they're going to turn to find out what's going on, and more importantly, when is it going to be over?
The dangerous cold wave of 2014 continues to push south over the United States, leaving a frozen world in its wake. Temperatures drop by as much as 50 degrees Fahrenheit, 10 degrees Celsius overnight. Detroit hits a low temperature of minus 14 degrees Fahrenheit. The temperature in Central Park in New York City is 4 degrees, breaking a 118-year record. The high in Cleveland reaches only 3 degrees.
When we get these extremely cold temperatures, schools are going to close. The schools are not going to have kids going to school. So parents need to pivot to try and cover to make sure that their kids are safe at home. They may have to stay home. Now you're impacting businesses.
With businesses closed, not even a home is safe from this cold spell.
When you're talking 20 degree below zero temperatures, your house may have never experienced that before. And you're going to hear sounds in your house that you've never heard before. There's creaks and groans as your house is trying to accommodate the extreme temperature change just in a small, distance between the interior and the exterior of your home. People's drywall could start to crack. We have things called frost quakes. That is an incredibly scary situation. It sounds like a bomb going off, but it's actually rapid ice expansion in the dirt around your home. It can cause cracked foundations.
Nashville, Tennessee's high hits minus 13 degrees Celsius. The strain on the power supply leaves thousands without power in Indiana, Illinois, and Missouri. Abandoned cars sit on the highways in North Carolina. Many authorities declare a state of emergency. Forecasters want to know what sparks the polar vortex in the first place. To get answers, data is required from the Arctic, one of the most inhospitable places on Earth. The National Oceanic and Atmospheric Agency, or NOAA, has partnered on a program using a fleet of drones that sail. These sail drones are used to collect important atmospheric and oceanic data from this remote and harsh environment.
So we took our knowledge from buoy observations, right? Picture like little miniature weather stations out there in the middle of nowhere. Buoys are fixed, they don't move. These we can move, we can tell them where to go if we see something interesting.
We use wind for propulsion. The wing tab allows the sail drone to steer with a very small amount of electric power. And then we use the solar panels that are on the vehicles to generate power for the sensors. We're able to operate for a very long time in areas that are very far away from land or fuel sources. We have designed these so that we can get data in the most extreme weather to help with weather forecasting.
The Arctic sail drone can collect roughly 2 million measurements per day, including wind speed, pressure, carbon dioxide, and air and water temperatures. The data are transmitted via satellite and available in near real time to both researchers and the public. Analysis of the data confirms the Arctic is warming and the sea ice is melting. Sunlight normally reflected away by bright white ice is now being absorbed by the Arctic Ocean.
You're taking away ice, you have open water. Open water is much warmer. First of all, it's much warmer in the ocean, but now you have this transfer of heat from the ocean to the atmosphere that didn't exist.
At the beginning of 2019, scientists detected a sudden stratospheric warming event in the atmosphere above the Arctic Ocean. The temperature over the North Pole is more than 50 degrees Celsius warmer than usual. The warm air helps to weaken and split the polar vortex over Europe and North America. The cold air causes temperatures to plummet, while Siberia is much warmer than usual. The shifting of the polar vortex has plagued Siberia with wide-scale wildfires, loss of the frozen permafrost, and an invasion of pests. In the winter of 2018 in Europe, a mass of cold air brings icy temperatures hovering between -16 degrees and -20 degrees. Snow is falling in Monaco, a Mediterranean city that usually enjoys mild winters.
This cold spell really affected all of Europe, and we can see that. On the contrary, there is cold all around Europe, but there is warmth at the pole, therefore warmer temperatures than normal. So in Western Europe and Mediterranean Europe, the cold is quite exceptional. We are used to having rather mild temperatures during the winter periods, which means our bodies are not necessarily accustomed to having such extreme temperatures, and so can suffer. It has an effect on the metabolisms and especially on the heart. Having snow in more Mediterranean areas always surprises us a little. There had been several centimeters of snow.
The eastern and southern parts of Asia are not immune from the effects of the polar vortex. Here, some populations that are unprepared for the cold are especially vulnerable.
In the year 2016, the cyclonic circulation in the Arctic has changed or weakened so that the cold air plunged into the equator regions and it has moved all the way to East Asian countries. In some of the East Asian countries, this cold air has created havoc, especially in the Hong Kong, Taiwan, China, Japan, and in India. More than 85 people died because of these cold events in Taiwan. Snowstorms happen in Japan, and it is also some people have died, and also few dozens of people in the Hong Kong has died in northern India, and it has formed a lot of fogs in the northern India, and it has affected the air traffic as well as most of the trains have stopped in that region. and it has created a lot of discomfort to the people. Unlike Europe and US, India is not prepared for such a cold weather conditions. So people are not aware of it, so they are not able to prepare well in advance. However, they have their old method of preparedness for this cold event, such as keeping the water bottles or thick blankets.
There is some evidence that rising ocean temperatures, disturbances in the jet stream, and increasing carbon dioxide in the atmosphere may make the polar vortex over the North Pole unstable. It could expand southward more often, sending more frequent or severe Arctic blasts into inhabited areas of the Northern Hemisphere.
The state of the climate. It's changing. Granted, it's always been changing, but it's changing differently than it's changed before. And the one thing that kind of comes up as a commonality in that change is, man, us. We're the ones changing it.
Human activity, industrial activity, cars, transportation, is polluted the atmosphere with more and more greenhouse gases. The one that's best known and is thought to have the largest influence on the climate is carbon dioxide. That leads to gradual warming of the atmosphere.
As far back as 1896, the Swedish scientist Svante Arrhenius hypothesized that changes in the concentration of carbon dioxide in Earth's atmosphere could alter surface temperatures.
It's called the greenhouse effect, because just like with greenhouse, you have glass, so it allows sunlight to come into the greenhouse, it heats up, but it traps the outgoing infrared or thermal radiation. A region that we know to warm the fastest, that the models project to warm the fastest, is the Arctic.
In fact, since the mid-20th century, temperatures have increased about twice as fast in the Arctic than in the middle latitudes of the planet. It's a phenomenon known as Arctic amplification.
This accelerated Arctic warming, this Arctic amplification, has created a very favorable environment for more of these disruptive snowstorms. These disruptive snowstorms wreak havoc. Here in Boston, the winter that everybody remembers is 2014-15, where we had 90 inches of snow in 3 weeks, and it was very difficult to travel. Roof collapses. And then besides the snow, you have the cold, which is dangerous and increases the number of deaths you get.
We can see that each year there is more and more melting of this Arctic ice pack. And this means that more heat is transferred to the atmosphere, because when the ice pack is there, it isolates the heat that is in the ocean from the atmosphere. And if the ice pack melts, there is more exchange of value towards the atmosphere and more atmospheric disturbances that can produce these winds that bring us cold spells.
What I am mindful of, though, is that the extremes are becoming more extreme. If I see the polar vortex beginning to shift, that's when my mind goes, okay, the forecast models are showing me a pretty extreme situation. Now it looks like those extreme situations could actually become more likely rather than the models just blowing it up into oblivion.
But not everyone in a position to take action on climate change accepts the facts. Politicians have testified that extreme cold weather disproves that the Earth is actually getting warmer.
We keep hearing that 2014 has been the warmest year on record. I asked the chair, you know what this is? It's a snowball. And that's just from outside here. So it's very, very cold out, very unseasonal. And despite a long list of substantiated global warming claims, climate activists and environmental groups will cling to any extreme weather-related headline to support their case for global warming and to instill the fear of global warming in the American people.
In 2019, after a polar vortex blew in, President Trump conflated the severely cold weather with long-term climate change by mocking global warming. Climate scientists know better.
It's overly simplistic to only say that climate change leads to warming. That there is actually, it's more complex, it's more nuanced, that there are other factors that are involved. What we're seeing, these cold snaps, these colder outbreaks, these snowstorms, is not inconsistent with climate change. That because the warming is not uniform, it can have kind of really important implications, consequences, repercussions for the behavior of the polar vortex, where the polar vortex is weakening more often than it used to, and once you get a breakdown or disruption of the polar vortex, the frequency or probability of getting severe winter weather, really meaningfully increases. It significantly increases. And if you weaken the polar vortex more often, that will contribute to these increase in episodes of severe winter weather.
The frequency of the polar vortex, especially the weakening of polar vortex, goes on increasing year by year, especially last few decades, and this will be going to continue in the global warming scenario. So we have to be prepared for such cold events in the East Asia region and mid-latitude regions.
I think we will see on average a warming of the climate. But also, we will see an increase in sustainability, that is, more heat waves. But also, perhaps more cold spell episodes. Afterwards, the problem is whether the average increase in temperature will be compensated for by the increase in cold spells. These issues are still very much under discussion at the moment.
After more than a week of cold temperatures, the Great Lakes of North America begin to freeze. Lake Erie is almost entirely frozen due to its shallow water. 2 months later, the rest of the Great Lakes are nearly frozen over. The thick ice cover traps ships on Lake Superior. Supply lines and economies are disrupted. A United States Coast Guard icebreaker struggles to keep shipping lanes open. On Lake Erie, where the water temperature is just below freezing, frazzle ice, a collection of loose, randomly formed needles of ice, is about to cut off the water supply of an entire city.
And in this case, it turned out to be the city of Avon Lake's water intake in Lake Erie. So the water temperature is 32 degrees, and because the water is roiling, it's always moving, you don't have any ability for those ice crystals to begin to solidify, unless they touch something that is also below freezing. And we have ice crystals, unbeknownst to us. We can't see them, they're microscopic, but we had all these little ice crystals floating around in that water. So you have a very rapid ice buildup on the water intake for an entire water system that feeds a city and areas beyond. And now they can't pump water into the water treatment plant. They also have a diver who is going down to inspect that water intake. And sure enough, that baby was frozen solid.
The mayor of Avon Lake warns residents that the city will be out of water in hours. In the middle of this historic polar vortex, 200,000 Ohioans across several counties are about to be hit by a veritable drought.
Almost with giant generators pumping in the water to supply an entire city with water.
With the danger now over, water restrictions are lifted. Nevertheless, the polar vortex continues to blanket the American continent. From the Rocky Mountains to the Atlantic Ocean, the frozen Great Lakes to the tropical climate of Florida. More than 200 million people, over half the population of the United States, are affected. At Disney World in Orlando, the high temperature one day earlier was a mild 75 degrees. Now, the thermometer drops to 34 degrees Fahrenheit, 1 degree Celsius. A wind chill advisory is issued for most of South Florida. Homeless shelters are opened. 2,200 residents of Pensacola Beach lose power after increased electricity demand causes a shutdown of the local utility. It is the beginning of spring 2014 when meteorologists expect average temperatures to return. A ridge of high pressure finally moves into the eastern United States, bringing average and above average temperatures to the region. The cold wave that came down from the Arctic is over. More than a dozen deaths are attributed to it, with dangerous roadway conditions and extreme cold cited as causes.
Here in Northeast Ohio, we were most impacted in early January by the polar vortex. It's funny now that the PV is out, right? So everybody knows what the PV is, the polar vortex. Now we can use that a little bit more, and we are starting to see, people respond to that. They know it's going to be cold when you say polar vortex, and they know it's going to be colder than normal when you say polar vortex.
It's very disruptive to society. 1% of mortality, is due, people that die in a year is due to extreme cold. The cities that see the greatest number of deaths are the coldest cities. So places like Cleveland, Detroit, Chicago, Minneapolis have the highest death rates due to cold, and these are the coldest cities.
It is the worst weather event for the economy since Hurricane Sandy that struck a year earlier. With 20,000 cancelled flights, airlines lost millions. Gas prices in New England hit record levels. Losses are estimated at $5 billion. The polar vortex is changing. It is affecting more people and larger areas around the world. Neither nations nor continents are immune to the icy blast of Arctic air. It's a global problem that can no longer be ignored.
So, our society developed around the climate and the weather that we currently have. So any shift away from the current climate and the weather that we experience is most likely to increase, will be a more hostile weather and climate to society. As a society, it is in our best interest to come together, in an instrument like the Paris Accords, to try to mitigate and try to reduce our dependence on fossil fuels. There's lots of benefit to societies to come, work together to mitigation of, the worst predictions of extreme weather that are expected with climate change, and continuous increase in greenhouse gases.
If we follow the Paris Climate Accord, it will be always possible to contain the polar vortex. Basically, the carbon footprint has to be reduced in such a level so that we can reduce the polar vortex in the coming years. The global warming scenario continues to go on, then the Arctic sea ice will melt completely, especially during summer. By the year 2050, we will not have sea ice in the Arctic. Few decades ago, maybe in 1980s, in Antarctica, there was a ocean depletions. And by that time, the Madrid Protocol has come into force, and it has been world over the carbon footprint by reduced by changing the gas in the fridge and other places, so that we are able to reduce the carbon footprint, and we are able to see that the ocean depletion has come down in Antarctica. Similar way, in Arctic too, we have to follow the Paris Protocol to contain the carbon footprint, either by individual or by the government or the societies.
Arctic de-amplification is still possible this century, which may help reduce potential increases in persistent extreme weather events. Some climate scientists believe a reduction of air pollution in the industrialized countries could actually restore some of the natural temperature difference between the middle latitudes of the globe and the Arctic.
I don't think we fully understand what are the consequences of climate change. In my lifetime, there have been a lot of surprises. And as I'm talking to you about what, the behavior of the polar vortex, that was not, even considered 10 years ago, 20 years ago. So that's both a source of comfort and concern. We grew up in this very optimal type of climate, and we're really, playing with fire when we're changing that climate. And inevitably, I think almost inevitably, a change will be a change for the worse, not a change for the better.
But in the short term, some countries are discovering the best way to save lives is to provide affordable housing and shelters.
Since we cannot prevent the polar vortex, we have to make comfortable shelters for the people to hide from the polar vortex. Otherwise, it will be difficult for the human in the years to come. Since polar vortex is dangerous, we have to prepare ourselves both before warning as well as the prediction system has to be improved so that people can be saved at least 10 days before in time.
Already, in terms of procedure in France, we have a winter plan that is systematically put in place at the beginning of the winter season to, among other things, protect people who may be a little bit subjected to extreme temperatures, as we have experienced during cold waves, and we will act as an alert. We have a vigilance system that has been extended to show the risks that we could experience in the next 7 days.
Despite the risks of bitter cold, the polar vortex creates some incredible displays of nature.
The polar vortex episode of 2014, we were introduced to light pillars. Basically, it's suspended ice crystals. It's cold and you're freezing, but oh my gosh, it's so beautiful to see the light stretching off of any light source. And that light is just refracting and reflecting off of all these tiny ice crystals that are suspended in an Arctic air environment. It's just stunning. And, you know, we saw in 2014 some of the more beautiful results of these ice shoves or ice heaves on the south shore of Lake Erie from Cleveland all the way to Buffalo, of just huge blocks of ice. And people were out climbing on them and all that. We had snow rollers, we have very cold temperatures, and we had high winds. So basically, that snow begins to move, and it's literally the little snowball rolling up.
When the lake freezes over, incredible slow-motion waves of crushed ice emerge from the shoreline and gradually plow through anything in its path. By January and February 2014, record-breaking low temperatures and snowfall amounts struck parts of Canada and the eastern United States.
We hadn't had cold air like that for 20 years.
And yet, 2014 would not be the last of these mysterious migrations of the polar vortex. The most recent being January of 2021, and it too proved to be as historic as some of the coldest weather ever recorded in the southernmost region of the United States. It paralyzed cities like Houston, Texas, Little Rock, Arkansas, and Hastings, Nebraska. Temperatures plunged to as low as -30 degrees Fahrenheit, while heavy snow and ice storms left millions without power and triggered catastrophic freeway pileups. But as scientists and politicians continue to debate the role global warming plays in the root cause of these disruptions of the polar vortex, what's becoming more and more certain is what happens when these disruptions do occur.
I do think having extensive periods of severe winter weather, extreme cold, and heavy snowfall are becoming more and more dependent on a breakdown or a disruption of the polar vortex.
Very, very cold temperatures and the pain that can inflict on people and the literal body hurts that they can have. But man, there's some fascinating things that happen too. And that's where you just start to have an appreciation for all things weather, atmosphere, earth. It all comes together, and I'm just the lucky person who gets to tell people about it.
It is one of the most mysterious regions on Earth. We are only beginning to understand how weather works in the Arctic. But when it comes to the meandering polar vortex, what we do know is that what goes on in the Arctic doesn't always stay there.